Yeah, we're thinking maybe that we needed to sell the name a little bit better to help draw the crowds in. We probably could have had the word sexy in there or something like that. But anyway, we're going to talk about Edgeguard, and it's great to be here. Just allow ourselves to introduce ourselves.
So yeah, my name is Owen Keary. I've been involved with OWASP for 10 years, maybe. I suppose what I do very much is I've been a developer. I've been a sort of a pen tester, and currently I'm the CEO of a European-based vulnerability SaaS called Edgeguard.
Irish-based.
Irish Europe.
Irish European.
Indeed.
I put the photos up there just so you wouldn't think that Owen is Raheem.
Well, that was St. Patrick's Day.
That's exactly. That's pretty much what you look like in the office day to day.
Yeah.
So. My name's Raheem Gina. I'm Irish from Ireland, but I'm half Indian, so I've got the Indian name and the Irish sense of humor, or so I like to think anyway. So I'm COO of Edgescan, and I've been involved in OWASP for a long time. Not so much active these days, and I used to live here in LA as well, so it's great to be back.
He also does Borat impersonations for parties, bar mitzvahs, and so on and so forth.
That was that was while I was living here, and actually had to pick friends up from LAX that day dressed like that. And some people got it. Some people were just looking at me very strange. Anyway, just a little bit on the just overall how this is going to be structured. I suppose introducing Edgeguard. It's just some code that we've open sourced as a project. We'll go into the background as to the attacks and risks and why we did this, the motivation, etc. We're going to go through the product, what it does, or the code, etc. Not a certain level. We're going to try and demo it. The Wi-Fi here has been a little bit flaky, so we'll try our best. And that's it then, really. So
it's very much around the idea of DOM security. So attacking people's browsers such that things like back-end security systems wouldn't detect this attack. There's a lot of sort of things like banking trojans, malware, like Dridex, for example, etc., etc. And a lot of them, once you get infected and you visit a particular, say, banking website, they wake up and then they start to rewrite your web page. So if I visit bank.com, in effect, these things would start to rewrite the HTML and therefore convince people maybe to send data such that it could be harvested. This type of attack is very difficult to detect because nothing hits the bank's back end, right? So it's all DOM. Also, the idea of DOM XXS in general as in the security industry is quite difficult to detect. It's been one of those elephants in the room, which we've never really cracked. In addition to the idea of DOM XXS, because generally it doesn't make HTTP requests, it means we can't proxy it, and therefore it's difficult to test for the tester as well. But the idea with Edgeguard is in effect to give you the ability to see if a user of your web application, a user if you're working in banking or if you're working in some sort of retail business, it can in effect help you detect if one of your users is infected with something, because you can't really determine if your user has antivirus, if they're, God forbid, still using Windows XP or IE6 or something like this. A lot of people aren't like most of us here in this room, which are tech savvy people. People just use the internet like they use a blender or a toaster to do their banking. So in effect, they may not, they may be infected for quite a long time. And the idea of client side and DOM security is to sort of, it's a very, very difficult problem to solve. So the idea with Edgeguard is to try and help you detect this stuff. And we've sort of open sourced it to that effect because we think people could maybe expand on it into the future.
So, malware is one aspect of it as well. As Owen mentioned, it's very much focusing on your end users, client type. I suppose it's a detection framework. If you're thinking about, attackers attacking companies, organizations, servers directly, at some point they figured out, hey, why am I attacking this bank directly when all I have to do is attack its end users? Why go after, Fort Knox when I can just, hit my grandmother who's trying to log on to her online bank? It's a lot easier. So ideas, things, obviously, there's the malware aspect where maybe a computer's been infected. It's hijacked the browser, hijacked the DOM in some way to try and exfiltrate data, etc. As Owen mentioned. As well, one aspect of it, which Edgeguard covers, is for cross-site scripting attacks, DOM-based and reflected as well, and HTML injection. Things like cookie theft, where you get hijacked, cookie gets stolen, somebody can then use that to perform session hijacking. The idea where you might have malware, etc., doing key logging locally within JavaScript. And then, of course, phishing attacks, where you are, your end users are, broad scale phishing attacks or spear phishing, to try and take some data of use from them, trick them into disclosing whatever that is.
So the risks are very much around fraud. Fraud, PII or personal identifiable information. Bottom line, if you steal that, what are you going to do with it? Commit fraud. If you're going to steal intellectual property, what are you going to do? Commit fraud. Botnets, the big trend now in botnets is hooking people to be cryptocurrency miners. A lot of that's JavaScript based. It's the idea is that your DOM gets infected, and then you have this JavaScript code running. Again, a lot of the JavaScript code, a lot of the cross-site scripts obviously do off-domain requests. So they're outside of the domain of the legitimate application or what the user is actually doing. And then we also have a tribute to Rick and Morty called Terryfield, which is just something that we particularly like.
Well, I was going to say on another slide that there's two badly hidden Rick and Morty references in the slides, and if anyone can pick out both, then there might be something special for them.
Even though we've nothing to give them.
Well, we can talk about that.
I'm not going to get bogged down in code here, but this is sort of an example of a DOM cross-site script. So you have a URL here, and you have an anchor or a hashtag after HTML. The hashtag or anchor is in effect in W3C parlance is called a URL fragment, and anything after that doesn't get sent to the server. So the server only sees the request to load a page. The JavaScript then, when the page is loaded, in effect grabs anything after the name parameter and in effect just rewrites it. So that's a typical DOM cross-site script, right? It's nothing special there. The point to be made is that the backend server, your IDS, your IPS system, your $1 million shiny box with lots of lights on it that's meant to protect your enterprise, doesn't detect this attack on your users, right? So what we're trying to do, in effect, even though we're repeating ourselves, but somewhat in a more deeper way, is the idea that it's difficult to detect DOM. It's difficult to test for DOM because DOM is doesn't generate HTTP requests. So if any pen testers here, hands up, right? So there's one. Anybody else? Developers?
You're not a pen tester.
So the idea is, I don't know, are we dev folks? Security people, dev? Okay, so I don't know if you ever use a proxy like Fiddler or something to test something. If you put a link in with a hash in it, anything after the hash doesn't go through the proxy. So how do you test for that? How do you detect it? So the idea with Edgeguard is it gives you the ability to try and pick up on some of this type of stuff. So again, if you look at sort of a lot of the tools, the commercial tools out there in the industry, they all go on about detecting cross-site scripts. Most pen testers find lots of them every day. The novelty of finding cross-site scripts on websites wears off quite quickly. But it's a little bit more difficult. So you can either use SAST or static analysis techniques to detect cross-site scripts, or IAST, to certain degrees as well. So the idea of testing using traditional pen testing methods for DOM issues can be a little bit more convoluted. It generally, the pen tester needs to understand what they're testing for, which isn't always the case as well. In effect, the idea of detecting this, because let's not focus on cross-site scripting all the time. What we're trying to do is detect any attack on the user's browser, right? So this could be a malware base, it can be an off-site redirection, data exfiltration from their browser. They think they're submitting it to the bank, but it goes off to somewhere in Dublin, Ireland, for example, rather than in the US. Typically, people would say Russia or China, but I'm actually going to say Dublin, Ireland, because there's plenty of evil people there. And the idea will be how do we detect that? And with Edgeguard, it helps you detect that type of thing.
So, Edgeguard, just kidding. Really what it is, I suppose it's a framework, and it's all, I suppose, written in JavaScript, for JavaScript. The idea, as we've sort of said, it's to detect attacks against end users, really, browser-based attacks. And the idea is, obviously those attacks, where people are going to have data stolen and things like that. It's very much a detection control, I guess. I suppose often a lot of security folk focus on, different types of attacks. A lot of the talks I go to, not just this conference, but lots of conferences, there's always different types of attacks, new avenues to attack different things. Fundamentally, a lot of the problems are still the same. So, part of this, internally we do, projects, stuff that we think is cool. And the idea is how do we help people defend against lots of these types of attacks? So that's kind of the motivation behind this sort of stuff. And it's not foolproof, but it's a start, something we found interesting, and hopefully anyone here finds it interesting too.
It's free.
It's free.
Yeah. So this started off as a sort of a product idea within Edgeguard, but we found it was better to give it to people to play with and build on it. So for example, there's a project in OWASP called AppSensor. Anybody familiar with AppSensor? There you go.
Is it still live?
I think it still is. I'm not sure. A lot of projects in OWASP tend to sit around in limbo. But so AppSensor will be sort of a thing where if you can detect malice in your application, you might be able to do something about it before things get exploited or whatever. We felt like that this wasn't the way we were going to go with the company. We said, listen, somebody cleverer than us will take this and use it and build on it. And that's sort of the idea. Do you want to explain this?
Or we might do it ourselves at some point.
Yeah.
So this is really how it works in a nutshell. So you have your own web application that you want to defend your end users. So what you do is you include Edgeguard. So your end users go visit your bank, their banking site or whatever. You have Edgeguard in place. It'll load that up and it'll effectively work within the contents, the DOM of that browser for that session. So the idea there is that that's all fine. Anyone who doesn't have a problem with their site, they have all their antivirus up to date. There's no attacks there. That's fine. Nothing happens. Let's say, for example, though, moving from number 2 there, if your end user is somebody who never has installed antivirus in their life, their machine is riddled with malware, maybe they've just been subject to a phishing attack or another type of cross-site scripting attack, reflector cross-site scripting. What the idea there is, whatever the attacker wanted to do at that point, probably something like either forging a transaction somehow, or taking the data directly from them, maybe something they might use later. Then the idea is that Edgeguard kicks in when it notices the abnormalities, and we'll go through what that means. And at that point, it sends some type of cross-domain alert to, effectively, you probably in any kind of realistic production scenario, you want to feed that into a SIEM or something like that, some kind of security event management system. We have a very simple logging plugin just to demonstrate it.
So what we could have done is, and people can do this very simply, you get a message from Edgeguard on our logger. We'll see a demo of this shortly, but when you get the message, you may want to be able to kill the user session. You may be want to block or prevent Edgeguard in its current form logs and tells you. Blocking and preventing things in a false negative way can be a career limiting move. But something else just to focus on this is that the web application here with Edgeguard, and it's not a plugin or anything like this, it's just an include, right? So the idea will be that the browser includes, in effect, a JS file in their web application. That's all they need to do. And in effect then, there's a separate, in the case of this demo, there's a separate AWS-based server which catches logs as bad things happen on a client browser. Yep.
Okay, so how does it work? Well, the idea is it really looks for certain types of things, changes, mutations, etc., that happen in the DOM. And we'll go through them in a bit more detail. But the idea is there, cross-domain requests in particular, and a few different types of aspects of in JavaScript. If it detects changes, things like anchor tags, HTML forms, image source attributes, there's a big list of things there it goes through. If there are abnormalities there or mutations, it should send, the idea is that it sends an alert, and therefore that's what you then.
So very simply, the idea would be, if I was going to steal data, with malware, my malware, or let's focus on malware, for example, it would may rewrite a page and put in a false login page or something like this, asking somebody to re-authenticate or something like this. And obviously, when they submit that data, it would shoot off somewhere else, and it wouldn't be obviously to the bank. So in effect, Edgeguard would detect that cross-domain attack. In addition to it, it also detects mutation. So we're using the object mutation API as part of Edgeguard. Object mutation API is a W3C standardized API, which in effect monitors the DOM all the time. And if something changes the DOM, it triggers an event and you can do something with it. So in effect, the idea with the list here, but basically HTML elements. So if a HTML element is injected in line, or if there's sort of some sort of injection attack, the idea will be that this mutator would wake up and go, I see this page has changed, and therefore detect the actual attack.
Yep. So as we said, the developers of whatever website they want to protect, they will only need to include the JS. The idea there is it loads first. How it sends the request is it uses cores and HTML5 for more modern browsers and falls back to JSON-P for older browsers. It's 6 KB, so it's not huge. We're trying to keep it as light as possible. And that's really it. But the main, I suppose, one of the main things it focuses on is utilizing the mutation observer APIs to, to check out for any kind of strange, abnormal behavior. So I think we'll try to have a little demo, which might
You're
make
using the California.
I'm using Santa Monica Wi-Fi. I thought there was going to be something in here, but we'll see how it is. It was it's yeah. Well, there you go. So look, we'll give it a go. We'll see how we get on.
Otherwise, we can talk intricately about the slides.
We could. Okay, so look, this is just an example of a hacked website. Okay, it's damn vulnerable web app for anyone who recognizes it. It's a handy tool. What we've done is we're using this as our dummy any app. It could be a banking site, could be whatever it is. We've changed it slightly to introduce different types of attacks that you might find. If you've been phished or if you have malware, DOM injection type stuff.
So what we have on the other side is the logger.
I know, I'm trying to get the logger.
We haven't rehearsed this too much, you probably know this. So on the other side, we have a logger, it's in AWS. It just sits there waiting for connections. So because it's using cores or JSON-P, if something happens on one of your browsers that's being affected, that browser will in effect, if it has Edgeguard, if that app has Edgeguard installed in your browser, it will actually send a message to our Edgeguard logger and in effect saying something weird has happened. So in effect, what we're doing is we're taking everything away from the back end and in effect detecting malice on the client side.
Okay. Let's see. So for the first one, the first type of attack, we just have a couple of samples here. Would be, adding an image, using image source attribute and pulling in something from, you could probably maybe use this for session hijacking, grab the cookie, send the cookie for this browser session to another domain, that type of thing. So the idea here is that this is already a user that's been hacked somehow, and hence the detection framework kicks in.
So just to explain a little bit more, if you can inject an image tag into a user's browser, the image has to load from somewhere. And in effect, if you can do that, it means you're forcing the browser to load, make a request to somewhere to load this image that maybe doesn't exist, right? And therefore, because we force the browser to make a request to somewhere, wherever this fictitious image is, we can steal other pieces of data and add it onto that request, and in effect steal people's cookies and stuff like that.
Okay, so just to show you as well, I just have it plugged in here. This is Burp Suite. It's just a web proxy. If you're a pen tester, you'll probably know what this is. Developer maybe as well. It's a client-side proxy. So what I've done here is I've proxied the demo vulnerable app, DAM vulnerable web app. So any requests, any communications it tries to make to the internet will go through here. Just to sort of highlight some of the activity as well for these fictitious attacks. So let's just say, we had the add an image one, right? So nothing happened. We don't see anything. In the background, we see a request here to your evil server, and the request literally grabbed the session ID there and posted off to my evil server, which is my phishing site that I'll set up. Just my listener. That's where I'll get all the data, the collection point. So the idea there with Edgeguard, then what it picked up, this was the user's browser, the one that was attacked, made an outbound request once it noticed that somebody had actually maliciously inserted, used the image source mutation. And so what it did is it sends a request from that browser to our logging service. So again, this could be probably be a seam. What you do with this at this point then is up to you exactly. If this was a banking site, and depending on maybe the URL or whatever was what the data that was coming in here, you might want to do certain things. Let's say, for example, that's some person's account. You might want to maybe put a fraud watch on that account. You might want to contact that user and say, hey, I think whatever browser you're using, your home PC is infected or something like that. Or maybe you want to block their account or lock it or something like that. Again, it depends on what the app is, depends on what your business is, but there's tons of use cases for it anyway.
So let me recap here, right? So I'm on Chase Manhattan Bank or something, more closer to home. That bank has Edgeguard.
I think it's just called Chase.
Is that what it's called?
Just Chase.
All right, Chase Bank. And in effect, what we have is it has Edgeguard installed, and we have our catcher sitting in some sock somewhere. If a user of that banking application was infected with this type of attack, Edgeguard would see there was a vector here, which is the mutation, which means an image source is created on the page. Here's the link where the image source is being pulled from. So in effect, it forced the web application to make a request to evil.com, and this is the IP of the infected user. So in effect, all of a sudden, because traditionally we don't really have much visibility over how secure our users are, what we have now is a timestamp. There's a lot more information here as well. Nothing personable, identifiable, but things like the time this happened, maybe what page the user was on. So you can see it was on this page here. And in effect, the SOC could see one of my users seems to be infected. A link off-site, was sent. It looks evil. Here's the user's IP. Here's where they were in the application. Here's the timestamp. And in effect, then with some jiggery pokery on your back end, you could probably figure out what individual is infected. They give them a call and say, "Hey, did you ever hear of antivirus?" or something like that, right? So it's sort of that level of visibility.
I mean, you could as well. You could include some kind of unique per session token or something like that
whatever
to
you want.
identify users.
It's up to you to play with it. Yeah. Well, that's a really good question. We've thought about that, right? We said we'd build it this way. You can do anything you want with the event. This is open source now. We didn't want to start blocking stuff because if you start blocking legitimate stuff, what you can do, let's say a lot of sites do have off-domain requests already. You can actually whitelist those so they wouldn't come up here as events. Like this, you're pulling, iframes or whatever from other sites and stuff. But we didn't want to get into the idea of blocking stuff because that can be, as somebody told me before, a career-limiting move in terms of you're blocking people's legitimate stuff, right? Now, but it's super possible to be able to do that. You can do anything you want. Once you detect it on the client, you could actually then get the client to do something and not come back. You can do whatever you want, right? But for the purposes of this sort of open source version of Edgeguard, it's very much you can just run this to see how it goes and then go from there, build on it.
Okay. All right. Next example here, we've just an insertion of a fake login. So, if I'm being phished, I get this other login prompt. It's obviously engineered to look like the real legitimate site that I'm expecting. I don't know because I'm just an end user. So I obviously type in my password and click login, out of the way, little box. And we can see here I've been redirected to evil.com, which we use an example that it is actually a real domain. They must get for sale, weird, I believe. So. They must get weird traffic from us because it's in all our demos for everything. But if anyone's actually ever looking at the logs, that is. So what happened there? Well, let's have a look in our proxy. So we can actually see that it made a GET request to evil.com with the password, username and password that I put in. So the idea here is here we go. Edgeguard anyway. So the affected browser, which has Edgeguard running in it, picked up two things. The fact that there was a form action create. So, the DOM was manipulated to create this fake form, which had, a path that was not expected. And then as well, the submit as well. So there's two. So
even if the user didn't click on the form, the monitoring people looking at this would actually have seen the form action create already. So maybe they didn't fall as far as to submit their stuff, but you can still see that something weird happened to that user without them losing their password. So we're sort of looking at two pieces there. It's the off-domain transmission of your data outside of your application, and it's also the mutation, which is the insertion of the fake in login form in the first place.
Okay, cool. Another quick example here. This one just changes links. You can see here, see the instructions link there. If we look at the URL has been changed to evil.com again. Obviously, if we're not looking at where the sources have changed, we might be
to a phishing website or something like that.
Exactly. Yeah. So we see, it again logs those types of vectors too. Let's see here. Fourth one, fake homepage. We have the home link here has been rewritten. So hovering doesn't actually show in the status bar that it has actually been rewritten, but it has. So when you click on it, you'll see we've redirected that to our fake site on a different domain. And again, those types of events as well. Is the href was mutated, so pick that one up.
So we're just demonstrating there is the last example there was the injection of a piece of JavaScript, but it's not inline JavaScript. It was an event handler. So the event handler overrode the actual click, and so the event handler, if you dig it into it with the Chrome tools or something, you can see that it overrode the fact that if you click on a certain href, it actually rewrites the href and sends out. So it's a piece of JavaScript as opposed to an inline injection of HTML or href.
Cool. And last example here, where we're going to send the entire DOM at that specific moment using an XML HTTP request to another domain. And if we have a look here, we should see there was a post request there to our arbitrary domain. That's a giant parameter there, data, which was the entire contents of that DOM at that time, that page. So if there's obviously any data there we want to scrape or whatever, if you're an attacker, that's a useful thing to do. And then we can see here, the logger picked up the fact that it was an off-domain request with exactly, yeah. So yeah, that works. Yeah, great.
So how it works, kids? Yeah. Woo. Okay.
So
let's just a little bit more. We have all those examples in
some examples there anyway.
You can see the source code of the injection stuff. We don't need to go through that.
Yeah. So that was the idea there. Yeah. So just a little bit on the alerting side, I suppose, Logger, it's just a very basic logging tool. There is tons of other stuff you could put in there. We've some ideas of stuff we want to add. I think plugging it into a seam is really where
threat intel
or yeah, exactly, and then using that wherever internally, however you manage your own security events, that type of thing. Anything else there?
Anything else cool? No. Pretty much though. It's all there. Again, I said they are timestamps. We don't pull. Let's say if there was things by default like identifiers, which will identify an individual. The reference implementation doesn't do that because for personable identifier information, PII reasons and for
data
privacy
protection
reasons, pretty big thing
in Europe is quite strict. So yeah.
So
a little bit more lax over here. But, it's all good.
We're all chilled, but
yeah.
So it's the idea is because it's a CORS request, you could send it to a SIEM, you can send it to Intel, an alerting system, whatever you want. Again, it's there, it's open source, you can play with it as you wish.
So that's just a little bit on the logger, but we demo that, so that's no big deal. So there's a few other features as part of it. I suppose just background into how to do some of this stuff. The scripts that are loaded, obviously, you can look through what points of the source code various things happen. The idea is that obviously it loads first. From that, there is existing code detection. So there's a sort of a fingerprinting of existing scripts, and you whitelist these as well, so it knows what is when you're pulling JavaScript in for your own app, the legitimate stuff. It knows what's meant to be there and what's not. So the idea there is that if anything is altered, that's it's making a comparison that way. There's also the timers aspect of it. So if there is timers built into, people that have put in residual timers, they'll be detected. You can pick them up, just in case stuff is meant to load later on. The idea there is, Edgeguard to pick that stuff up.
So very much these various features are they're sort of built. We got Edgeguard, it works, and then hacker knows Edgeguard is enabled on this site, so they'll obviously try and inject something else, maybe a JavaScript to circumvent Edgeguard, or whatever that may be. So the idea with these is to try and get Edgeguard as a functional unit, to self-defend a little bit. But if you think about it, this is an arms race. I think every time a hacker will come along and be able to circumvent Edgeguard, what we've done in very much, I think, is higher the bar massively. But if you use Edgeguard as an example. But I think, wily hackers could circumvent Edgeguard, and the Edgeguard, whoever's developing it, would have to, go back and do more. Very similar to the, I don't know, for hacker people here, like the idea of X-frame options for clickjacking. And, before we had the X-frame options header, we had JavaScript trying to detect if I was in a frame or not. That might not make much sense to some people there, but the idea was it's always a constant arm race. So, you know, we're not saying it by any means Edgeguard is a silver bullet, but for your typical drive-by cross-site script or your typical malware, it could raise the bar dramatically.
Yep. Just a little bit more there on the overrides for WebSockets and XHR. So it's just pointing to where you can find all that stuff. You know, initially there's the DOM watcher aspect. So it'll, oh, sorry, should scrape. Scrape the DOM to see if you know, changes have been injected, etc. We're going to check the to see if new elements are created, and then also check the attributes as well to see if they've been modified. And that's really it. And so then, you know, there's a whitelist you can build in server-side config of domains that you know most rich web apps these days are going to pull in. Communicate with various different sites as well. Obviously they're, exactly. I mean, they're all legit, so you don't want nobody wants their logging system, false positives, etc. So, you know, you can whitelist them as well, so you just clear out all the noise. So yeah, I suppose closing thoughts. I mean, Owen really went through some of these as well. You know, I suppose, you know, like anything, it's not really ever going to be bulletproof. And again, it is very much sort of an arms race thing. It's like you up the ante, up the bar a little bit. You know, at least if you make your site, it's the same analogy that goes on. You know, if you make your site slightly harder to attack, you know, attackers of certain ilk will be lazy, and if that's harder, they'll just go into their competitor and attack them instead until they then maybe equal something, and then, you know, that kind of way. It's if you're, you know, the old adage, if you're being chased by you know, a bear, you only need to outrun the guy who's, you know, slower than you. So okay, so yeah, feedback welcome on it. Anyone gets a chance to play with it, that'd be cool. Just some stuff on the license stuff there. It's you know, free for non-commercial purposes. There's the code available there. Huge thanks to our CTO Owen Mooney, who did a lot of the groundwork for the dev stuff. Yeah.
So it's there, you know, try it out. I think it's reasonably easy to implement and understand. If you don't know JavaScript, maybe not. And again, if you have any questions, you know, we may not guarantee, you know, we're not going to have a support sort of agreement here. Well, you know, it's very much for every time we help you.
For a pint of Guinness, I'll give you his mobile number.
Yeah, but anyway, you know, the idea will be, if you have any thoughts or anything on how to play with it, or if you have any use cases that are interesting or anything like that, we'd love to hear it. It's there.
Yeah, and we'll be adding on to it over time as well. You know, there's tons of ideas there for things to add to it. Do you want to mention that?
Oh yeah, the stats report. So I don't know. It came out yesterday. It's not really. It's very much a technical report. It looks at things like DOM XSS, like client-side browser security. It's based on the assessment of thousands of full stack systems in the 12 months to December. It's probably interesting because I think if you read the reports, which is like most of the statistics I did myself, I do it every year. It's very painful, but we grab all the data, sanitize it, and build a report from it. Compared to some of the bull crap you get from vendors saying, you know, you better get, you know, my product or you're going to get hacked. It shows you the types of vulnerabilities. There's a new piece on it on the vulnerability taxonomy, which is the most common types of vulnerability, both in the host layer and the web application layer, and it's very realistic. There's no real stark 95% of all apps are in trouble. Any of this sort of malarkey, but I think it's reasonable. So, you know, it's on our site if you want to have a look at it as well. All right.
Cool.
Yeah.
Thank you, guys.
Yep. That's it. Any questions at all or anything?